Hello, calculus fans. Okay, we've got a water tank in the shape of an inverted right circular cone. The word inverted just means upside down, so that the pointy side is down. It's a right circular cone. The circular part just means that the top here is a circle. So we've got a sort of a three-dimensional view with a little bit of perspective. The water tank has base radius 2 and height 5. Now, that's the tank. Now, let's suppose that water is being pumped in at the rate of 4 cubic meters per second. We want to find the rate at which the water level is rising when the water is 3 meters deep. So now let's let V, R, and H denote the volume, radius, and height of the water as a function of time. Now, notice that they are the volume, radius, and height of the water, not of the tank. See, the tank, the radius and the height don't change. The radius of the tank is 2, the height of the tank is 5. That's not changing. Whereas the volume, radius, and height of the water that's in the tank is changing because we're pouring water into the tank. Now we're given that dV by dt is equal to 4. That's the rate at which the water is being poured into the tank. And then we want to know what dH by dt is when the height is equal to 3. dH by dt is the rate at which the height of the water is changing. Now we also know that the volume of the water is 1/3 pi r squared h. Again, that's the volume of the water, not the volume of the tank. The tank is not full of water. Now we should note that there is a proportion between the radius and the height of the water. And we're going to use that to help us eliminate a variable. So we should be able to see that r over h is equal to 2 over 5. Those are the proportions of the radius and the height of the water versus the radius and the height of the tank. This proportion has to be equal because there are similar triangles here. So we can use this to solve for r. R is equal to 2h over 5. And we're going to eliminate r in the expression for the volume. So let's go back now to our volume formula and plug in r equals 2h over 5. So the volume is 1/3 pi r squared h. And we're going to plug in 2h over 5 everywhere we see the r. And we end up with this expression. Now notice that this thing has no r's in it. We've eliminated the r so that we only have h. Well, let's simplify this a little. So we get 4 over 75 times pi h cubed. So this gives us an expression for the volume of the water just as a function of the height. We don't need to know the radius, because once we know the height, then we can determine the radius using the similar triangles that we talked about before. It is worth pointing out that the reason we're eliminating r and not h is that we're trying to solve for dH by dt, but not dr by dt. So we really want the h in this equation. Okay, so we should make a list now of our knowns and our unknowns. So our known quantities are that the volume is 4 over 75 times pi h cubed. We know that the height is supposed to equal 3. We know that the rate of change of the volume is 4. That's 4 cubic meters per second of water being poured into this conical tank. And then dH by dt, we don't have that. That's unknown. And it's important to say why dH by dt is unknown. The reason it's unknown is it's the thing that we want to solve for. We're interested in knowing what is the rate of change of the height as a function of time. Now, in any one of these related rates problems, you should have a quantity that's unknown. That unknown quantity will be the thing that we want to solve for. Now we have an expression for our volume. It's 4 over 75 pi times h cubed. And what we'll do is differentiate this, both sides, with respect to t. So if we differentiate both sides, let's see what we get. Remember that everything here, all the variables, are functions of t, functions of time. So after differentiating, then we get dv by dt is equal to 4 over 25 times pi h squared. Notice that we have to use the chain rule on the right-hand side to differentiate the inside function. We should think of h as the inside function, so we're getting dh by dt. Okay, we'll plug in our known quantities, which is dv by dt is equal to 4 and h equals 3. Keep in mind that this is the thing that we're trying to solve for, the dh by dt. Okay, we plug everything in, we get 4 is equal to 4 over 25 times pi times 3 squared times dh by dt. And now it's easy to solve for dh by dt. Do a little solving and we get dh by dt is equal to 25 over 9 pi meters per second. That works out to approximately 0.88 meters per second. You should be able to measure how fast it's rising per second, and that's what we get. Okay, that's all for now.